Hi everyone. Here question is check whether following automata M1 and M2 are equivalent or not. When we say two automatas are equivalent, when if we give the same input to both automatas, for example here M1 and input M2, input is same. So on the same input, if both automata are going to final state or both are going to non-final state, M1, M2 on the same input, both are going to final or both automata are going to non-final, then we can say M1, M2 are equivalent. If in case M1 is going to final and M2 is going to non-final state or vice versa, then we will say both are not equivalence. It means what? Both automata if are reading the same language or accepting the same language, if L1 is a language and L2 is a language accepted by M1 and M2 respectively, if they are accepting the same language, means this L1 L2 is same, or we can give the same name L, both are accepting the same language, then both are equivalent. Okay, if they are not, then they are not equivalent. Then automatas on the same input are going to the same state, final or non-final. It means all the states of that automata. If M1 is going to the final state, it means what? Q1 or Q2 or Q3 is going to final state. Same with the M2. Let's understand this concept with this example. In this example, we need to check whether M1 and M2 are both equivalent or not. How to check it? What is the starting state of M1? It's a Q1. So take it. What is starting state of M2? It's a Q4. We will construct the one table here, and from the table we can conclude whether both are equivalent or not. What are the input sets? C and D in both the cases. C and D. What are we doing here? As I mentioned, on the same input, M1 should go to final, M2 should also go to final. If on the same input M1 is going to non-final, then M2 should also go to non-final, then only we can say both are equivalents. Okay, so we are checking that one. If suppose input is C, then Q1 is going to, Q1 is on the C going to Q1 itself, so write down Q1 here. Q4 on C, Q4 on C going to Q4 itself, it's a self loop, so Q4. Now see Q1 Q4 on the input C going to Q1 Q4. Q1 is final state, Q4 is also final, so both are final. Q1 Q4 both are final, so no issue. On the input C, both automatas are going to the final states. Similarly, Q1 Q4 on D, it means Q1 on D, Q1 on D going to Q2, Q4 on D, it's going to Q6. It means Q1 Q4 on the same input D going to Q2 Q6. Q2 is non-final, Q6 is non-final, so no issue. Q2 and Q6 both are non-final. Both automatas are going to final, so no problem. Both are going to non-final, no problem. What we need to check more? Suppose on reading the input C and D, Q1 Q4 is going to some new set. Now example here Q1 Q4 is covered, but Q2 Q6 is new one, so write down here Q2 Q6. Again check the same process, Q2 Q6 on C, it means Q2 state reading C, Q2 state reading C going to Q3, Q6 reading C going to Q7, Q3 Q7. Q3 Q7 both are final or both should be non-final, that we need to check. Q3 is a non-final, Q7 is a non-final, so both are non-final, so no issue. Q2 Q6 on D, Q2 on D going to Q1, so write it down. Q7 on D, sorry, it's a Q6, Q6 on D, Q6 on D, it's going to Q4. Q2 Q6 on reading D going to Q1 Q4, so this is Q1 Q4, both are final, no issue. What is the new set here? Q1 Q4 is covered here, Q3 Q7 is new, then take Q3 Q7. Repeat the process, Q3 Q7 on C, Q3 on C going to Q2, it's going to Q2. Q7 on C, it's going to Q5. So write it down here. Now observe the scenarios. Q3, Q7 on reading the C going to Q2 and Q5. Q2, Q5 is what? Check whether both are final or non-final. Q2, Q5 both are non-final, so no issue. Means on reading the giving the same input, on reading the same input, these states are going to non-final. Both are following the same behavior, so it's accepting this input at this moment. Repeat Q3, Q7 for D. Q3 for D going to Q3. Q7 on D going to Q7. So Q3, Q7. It's covered here. Both are non-final. So Q3, Q7 on D following the same behavior. What is the new here? Q2, Q5 is new one. So Q2 on C, it's going to Q3. Q5 on C, it's going to Q7. Q3, Q7. So it's what? Both are non-final, no issue. Q2, Q5 on D. Q2 on D going to Q1. Q7 on D. Check the similar process. Q7 on D. Sorry, it's a Q5. Q2, Q5 we are checking. Q5 on D. It's going to Q4. You can check it. Q2, Q5 reading D. Q2 reading D going to Q1. Q5 reading D going to Q4. So Q1, Q4 both are final. What is the new here? Q3, Q7 is new? No, it's covered here. Q1, Q4 is covered here. So no subset or no set of states is new here. And all these four rows are following the same behavior. Either on reading C, it's going to both final state, or it's going to both non-final. So it's following the behavior. If M1 state, this Q1, Q2, Q3 is M1 state. Q4, Q6, Q7 are the automata M2 states. Both state on the same input following the same kind of behavior. Either both are going to final or both are going to non-final. It means what? On same input, states of M1 and states of M2 following the same behavior. Or we can say states of M1 instead of say I will say M1 and M2 following the same behavior on same input. Either both are going to final or both are going to non-final. As they are following the same behavior, then I can say M1 and M2 are both are equivalent. And this is our final answer. So answer of this question is both are equivalent as both are following the same behavior. Thank you for watching.